efficiency, innovation in predictive technologies, and to discuss the risk mitigation strategies. It's my pleasure to introduce the first speaker in this session, Professor Jun Yongling, Director of Research Vessel Operation and Management Department, Second Institute of Oceanography, MNR, China. The presentation entitled Research on Capacity Building of Marine Scientific Research Vessels.
Thank you, Chair. It's my pleasure to give the presentation. My presentation title is Research on Capacity Building for Marine Scientific Research Vessels. And my presentation will include in 3 parts. The first is the background. So, as you know, the ocean plays a crucial role in the Earth systems and is the source of food and nutrition for life. And the ocean provided the living marine resource, marine chemical resource, marine spaceport resource, and the marine oil and gas resource, and also including the mineral resource, things like noodles, crusts, and sulfur. And so the ocean research is a requirement for the exploration and development of the marine resource and protection of the marine environment. However, the ocean not only brings abundant resource to humanity, but also brings many disasters, things like volcano activities, tsunami, typhoon, and red tide. So the question is that, so how can human beings scientifically and reasonably develop abundant marine resource, and how can we effectively prevent it and reduce marine disasters? So the primary point is to have a comprehensive and scientific understanding of the ocean, including the various physical processes that occur in the ocean, its chemical composition and geological conditions of the seabed. Only by fully understanding the ocean can we truly achieve the utilization and harmonious coexist with it. Since we want to have some scientific understanding of the ocean, it is essential to have sufficient data. So here is a picture shows the ocean stereoscopic observation systems. In this pictures, we are including the remote sensing, airplane, and research vessels, and mooring systems, AUV, GRAD, and so on. It's obviously the research vessel will play a crucial role in the observation systems. So, what type of research vessel will meet the marine scientific research community? And as we know, different survey and research tasks will need a different research vessel. Normally, we will include in the following survey and research tasks, things like marine dynamic process and natural hazards, ocean circulation and climate change, mineral resource on the ocean floor, oceanic biological resource, environmental impact assessments, oceanic ecosystems and biodiversity, and observation of typhoon, mega-scale eddies, tropical cyclone. Also, we are related several measures, things like marine geology and geophysics, and physical oceans and ocean remote sensing, marine organism and marine chemistry, marine physicals. So, what kind of the research vessel will meet scientist requirements? So I just from the scientist view to raise the research vessels, and the research vessel is around the 4,000 ton levels. And the first, the research vessel should have an optimized hull design and very low underwater radioactive noise and vibration levels, and at least DP1 standards. So selection of the propulsion and the power generating machinery critical for underwater noise. And the second is green. We normally will use diesel electronic propulsions, low emission of CO2, and internationalizations, because the scientists come from not only from home but also from abroad, and convince the personnel movements between work area and accommodation, logistical scientific samples from the deck to laboratory and to storage. And comfortable, the research vessel should creating a safe, comfortable working and living environment. Modular science container template. This is very important for scientists, because the research vessel is very limited, but different expeditions, they need different equipments. So how to solve these problems? So we need a modular science container template. And the last is informatizations, because the research vessel will have a shipbound network and should have a land-based information exchange. So normally the 4,000-ton level research vessel should have the following characters. The first is to integrate multidisciplinary, multifunctional, and multi-technical capacities. The second is to conduct mineral resource and environment survey and research capacity. The third is a testing platform for high technology ocean technology. And the last is minimal fuel consumption and minimize the vessel environment impact and the carbon footprint. I list the recently in China deliver the 4,000-ton level research vessels. Although the research vessel is belong to the different owners, but they all have a common parameters, seem like they all belong to the global. And the length overall is from 19 to 100 meters, and the beam is from 17 to 18 meters. The draught is from 5 to 9 meters, and the accommodation is from 60 to 8 persons, and the range is 14,000 miles, and the economic speed is 12 knots, and the endurance is 60 days, and the maximum speed is 16 knots. And noise is DNV silent R, and the laboratory area is more than 360 square meters. Working after decks is more than 400 square meters. And the class symbol is similar like AUTO0 and OMBO DP1. So navigation, position, and communication is also very important for the scientists. For scientists, they not only just install the GPS or BeiDou, but also they need the DGPS. So normally in the research vessel, we will install the two independent DGPS for accurate research surveys. And for the communications, we use the Inmarsat L band plus K band and VSAT KU band. Last year, in the Eurofleet, they also use the Elon Musk's Starlink. And this shows DP1. And for the how to control the noise, normally in the research vessel we will have 3 ways. The first is floating raft isolations. The second is double isolation, and the third is cabin isolations. So to avoid the cavitation bubbles inference and get more accurate readings, acoustic transducers are critical for collecting the high quality data. There are 2 ways. One is a novel design bottom blister and with 2 jump kills. Normally, all the acoustic transducer will installed in the blister and two jumper kiosks. The other way is the gondola model. Compare the two models. Gondola model can collect the high quality data than the blister, but gondola model will consume more oils than the blister models. And octane and fins is also very important because octane or fins can measure the 6 degree of vessel, including the low pitch yaw, surge, sway, heave for the multi-beam, USB or attitude collection. So all this information and including the DGPS will to the multi-beam or USB-L. And the research vessel also should have several detection systems. So the research vessel can detect it from the air, sea surface, water column, and seabed. So the first is air and surface water sampling systems. The surface water and meteorological monitoring systems utilize scientific instruments to continuously measure surface water properties and meteorology. I listed some the equipment. And water column exploration systems to reveal ocean circulation dynamic process and material cycle flux. The vessel can investigate the integrated marine hydrological, chemical, and biological parameters. And the equipment will include the CTD, ADCP, and so on. And the seafloor exploration systems can undertake the task of exploring the surface of the seafloor and sedimentary strata. It equipped with the multi-beam and sub-bottom profile and gravity meters and so on. So deep sea extreme environment exploration systems can enable scientists to carry on comprehensive scientific investigations, observe seafloor topography and collect biological and geological samples in black and high pressure deep sea environment, including similar like TV grab and 20-meter riggers. And the research vessel also should have handling equipment and winch systems. A wider range of cranes with associated winches and wires will allow many different types of equipment to be deployed from the vessels, similar like stern A-frame, main crane, and port and starboard telescope crane. And the winch will also have including 4 types of the cables. The first cable is the steel-armed optical cable for high data transmission. The second cable is steel-armed electrical cable for high data transmission. The third is geological cables. We also call the steel cables. The last is CTD cables. Here is some pictures to show the winches and the cables. Shipboard network. Shipboard network including shipboard navigator and communication, data processing, network management, video monitoring, and shipboard entryment, and so on. So also we need we not only have detecting systems, also we need laboratories. So the research vessel will contain a range of laboratories space that can be flexible configured to support multi-scientific activities on each expedition. Normally, there is also the option to configure the laboratory space to wet or dry laboratories, depending on the nature of science being undertaken. And normally, here is a picture shows a range of laboratory space layout, including the geophysical laboratories and biological laboratories and acoustic laboratories and navigation laboratories and so on. So here is some laboratory pictures, and here is some control rooms, similar like controls ROV and similar like that. Except the research vessel, we also have the other portabilities equipment, similar like multi-channel digital seismic systems, and also some modeling system, ROV, AUV, GRAD, Argo, and recently is also very popular is BGC Argo. So here is a picture to show the exploration systems. So the research vessel arrives the due date. The multi-beam side scan ADCP will work together, and we can deploy the AUVs, and we use USBL possession the AUV, and at that time we can deploy the TV grab and so on. And so let's move the last parts. So in second institute now we have 4 relevant research vessels. The first is Dayang-hao, we are responsible for the vessel and the survey equipment. The second is Zhu Haiyun, we responsible for the vessel. And the Xiangyang Hong 10 and Dayang 1-hao, we responsible for the survey equipment. So I would like to introduce one of the research vessel, Zhu Haiyun. Why I introduce the Zhu Haiyun? What's the difference with the Zhu Haiyun with the other research vessels? The first is the Zhu Haiyun is the world's first intelligent unmanned research vessels, and the research vessel can autonomous navigation in open water. And last year we have already practiced it and is successfully. And the second, they can remote control provided with the crew members. And the Zhu Haiyun is designed and built to support a array of unmanned systems, similar like drones, USV, GRAD, ROV, AUV, etc., for an integrated ocean observations and testing new technologies. And the futuristic look is unique and amongst trans research vessels. So this PPT is provided by the Southern Marine Science and Engineering Guangdong Laboratories. The idea comes from the Professor Dick Chen of the second institute. He is also academician of CAS. So this picture is show how we use the Zhu Haiyun to observe the typhoons. So before the typhoon coming, the Zhu Haiyun will arrive the due areas and deploy the unmanned boat. And then the unmanned boat go down and around 60 meters. And when the typhoon is coming, and the unmanned boat will go up, and we hope the unmanned boat will happen in the eye of the typhoon. And then we can launch the sounding rocket. And during the sounding rocket fall down, they will collect the typhoon's data and then transmit back to the unmanned boat. And then unmanned boat will go down to the water. And after typhoon go away, and the unmanned boat can go up to the sea surface and back to the Zhu Haiyun. So we hope through this way we can collect the typhoon's data, and we hope know the interaction mechanism between the upper ocean and the typhoons, and include the predictive ability of typhoon intensity and marine environment during typhoon's process that will improve the human being disaster prevention and reduction capacity. Jacqueline, right? Thank you very much.
Thank you, Dr. Yongling, for this very informative speech. Thank you very much. I believe you faced a very big challenge in capacity building vessels. It seems very impressive thing. We will discuss you in the end of the session. And now I introduce the second presenter, Dr. Suzanne El-Gharabawi, Head of Marine Geophysics Laboratory, National Institute of Oceanography and Fisheries, Egypt. Let's welcome Dr. Suzanne. The name of her speech is Advancing Ocean Observation in Africa, a Valuable Resource for Research Institutions and Polymer. Welcome, Dr. Suzanne.
Good afternoon, ladies and gentlemen. Thank you, Mr. Chair, Mrs. Chair, Professor Ala. Today, we will talk about the ocean observations and how we could advance this for not only our resources and our research, but how to help and convince the policymaker in their ideas. As we know, ocean observation in Africa is a very important field of study and research because it focuses on understanding, monitoring different aspects of marine environment. We will find Africa as a continent surrounded by a whole seas and oceans. So we have a lot of marine resources, and we need to assess our resources and also to manage against the impacts of the climate change. We need to make observation about the physical oceanographies, the sea level rise, and also the biological activities. All of those will help the policymaker to take the right decision. We will see for today how we could do this. As at the beginning, we will have a quick look on the African continent, and we found that, as we say, Africa have a very long coastal lines and also a huge area of EEZ. With all of its coastal countries, which are 38 continents, Africa had also adjacent states or adjacent island states, and those makes a huge EEZ that need to be observed and monitoring for all the parameters. When we see what is the regional or the main bodies that work for ocean observation in Africa, we find here, if we look to the map, Africa have its regional observing system, which is GOES Africa, and we have Professor Afian, the chair of GOES Africa, with us today. Also for the northern and Mediterranean area, we are connected to the Mongoose. The Mongoose is for the Mediterranean. And also part of the eastern side is connected by the Indian Goose. So those are the main sectors that work for observations. But although we have those three systems, we still underrepresenting about the ocean observation and the monitoring due to the lack of the number of the active stations. If we have a look here, we will find the one here to the right is for the GLOES, the sea level stations, and we find they are so few compared to the size or the area, total area of Africa. And for the North Africa, we will find only 2 stations, one in Egypt and another one in Morocco. And this is so few to have an adequate monitoring for our seas. The other one is the sea level station, and this one is connected to the tsunami early warning system of the IOC. And also, when we take a close look to our area here, we will find that the only stations are in Egypt and Morocco also. Our station is in our institute in Alexandria, the National Institute of Oceanography and Fisheries, because we are the focal point for the tsunami early warning in Egypt. due to this lack of all observing system, we as African countries, especially IOC Africa, had taken the idea of making a roadmap for Africa and put some priorities. And as Professor Hamouda mentioned during the morning session, and also Professor Afian, this roadmap had been launched here in Cairo, in Egypt. And we were hosting the conference for this announced for the UN Ocean Decade Roadmap for Africa. We had 9 priorities. 2 of them are mainly focused on ocean observations, priority number 5 and priority number 6. Number 6 is mainly for ocean observations and forecasting systems in Africa, while priority 5 is for strengthening the multi-hazards, including the tsunamis, cyclones, and also the community resilience. And one of those major projects for the UN Ocean Decade is the coastal resilience for the Mediterranean, that we are also part in it. Then, due to our analysis of the challenges and the gaps we had in Africa for this important category, we found that we need a lot of help, especially for transferring the skills, the knowledge, the technology, and all these items, and make it connection with its human relationship with the ocean. From the study of the gaps analysis, we find that we don't have the common platform. Let us say it at the common platform, because what we had is just national centers, but we need to have a continent center, a center for data analysis that is cover all the African countries. And also, we had to work closely with the industry, especially the oil and gas industry, because they have a lot of surveys and a lot of work and a lot of data. So if we could have this data for observing, this will reduce the amount of money we need for buying new or purchase new instruments, and also their data are very accurate. So this will help us also. There is also a gap in situ observation, and this is really appear while any institution had its, for instance, example as a tide gauge. After a certain years, this tide gauge will not be working as good as it was before, and so this is what makes the decline in the observation in Africa, because when the station is not working anymore, so we lost the data from this part. Then we need, this turns us to the main important issue, which is the capacity building. And the programs for the priority for what we are looking for in Africa, especially for the ocean observation, is the capacity building. Capacity building for new instruments, for training of the researchers, and also make the data open for all the researchers. Then when we start to talk about the African countries and what is the initiatives and the organizations involved in ocean observations in Africa, we'll find that there is a category, a different category of people that are followed to this field of science. Number one, we could say the oceanographic research institutions, and we have a number of those institutions on different African countries, such as our institution here in Egypt, the National Institute of Oceanography and Fisheries. And also, many of the 38 of the African countries are part of the IOC, and they follow also the GOOS Africa. The regional oceanographic data and information centers, we need to collect our data to be one data, and also to be open for other and all the researchers from the African countries, and also the most important is to validate those data. We find that many African countries already had adopted their integrated coastal zone management strategies, and this is to address the challenges that poses the coastal development and the climate change. And while we are talking about the IOC and the goals for ocean observation, we find that number of African states and countries are affiliated and collaborated with the international organizations like IOC, and also several African countries have also worked now to establish their marine protected areas. And this not only for the help of defending the climate change problems, but also to support the ocean conservations. And the highest or the priority countries that have established their marine protected areas from long time are Egypt, Mozambique, and South Africa. For the satellite remote sensing, this is also a main topic here for ocean observation, because due to the lack of the instruments, so we could use the satellite image. And Professor Afian gave us a good presentation in the morning session about the use of the satellite image and how this could cover the gap. For the oceanographic research vessels, this is something that have a problem here in Africa, because not all the African countries have research vessels. And if they have a research vessel, does it fully equipped with the instrument that is needed for the observations? And this gives the National Institute of Oceanography and Fisheries the priority to be one of those, or the first institute that have research vessels in Africa and in the Middle East, which is fully equipped for instruments that is used for ocean observations. This is a quick video for one of our research vessels. Our institute had two research vessels. One is for fisheries studies and assessment of the biodiversity, while the other one that is showing on the video is for the exploration and marine observations. The research vessel is equipped with the main and important instrument for all the types of studies, exploration, and observations. As we can see here from the video, we found a lot of instruments. One for the side scan sonar, sub-bottom profiling, and streamers and sparkers for the seismic. At the same time, we had multi-beams for bathymetric surveys, and also ROVs and AUVs. The one showing now is the sub-bottom profile, and this is used for shallow seismic studies. As we see here, we could survey the sub-bottom of the seafloor, underneath the seafloor. And we have all the successive layers, and we could also detect the fractures. You could use also in oil and gas studies, for mineral studies, so we have a lot of applications. The another instrument, this one is for the magnetometer, and it's used for the magnetic studies, and this is the side scan that gives us a complete scan of the seafloor with high resolution and full coverage. We used mainly for habitat mapping, for archaeological studies, and underwater shipwreck studies. Those are some of our studies in the Eastern Harbor and the Old Harbor of Alexandria, the ancient Cleopatra's Harbor, and some others from the World War, Second World War here. As we could see, our vessel could have the ability to deploy up to 3 instruments towed at the same time. This is the control unit inside the research vessel that controls all the instruments while we are working. Some of the cabins just appeared on now, and this is the ROV. We had a set of ROVs in the National Institute of Oceanography. This is the one which is the industrial ROV. It could reach to 1,000 meter depth, and we have others like this one, a small one for the shallow areas, especially for the coral reefs. And here we could see some seepage comes out due to oil and gas seepage. And this area had been detected by our group in the institution. This is also from the control unit inside the ship. The last one here is the streamer sparker system and the water quality. The streamer sparker system, we use it also for seismic surveys. As we see from the video, we had the capabilities in our research vessels. And this is why, as Professor Hamouda mentioned in the morning, we bought the African cooperation and to make a capacity building for all the African researchers and the students in our institution. And this is the role of the China-Africa Marine Science Center for Blue Economy that had been established in our institute last year. And this is our mandate, and this is what we are needed to do. Another thing, when we talk about the regional oceanographic data information centers, when we look about the data and information in Africa, we find we have 5 centers that covers the African region. The north one is hosted in our institute in Alexandria. The southern one is in Cape Town in South Africa, then the western in Senegal, the eastern in Kenya, and there is another one in Mauritius. The idea of collecting and archiving this oceanographic data is just to provide an access and make it easy, and also to share the data to the institution, the researchers, and the organizations, and also for the regional stakeholders. And those are the main targets we need to confess them so we could have fun and start to do our work. On the other hand, if we talk about the regional networks in Africa that is focused on oceanographic data management, we find we had a lot of networks. Those number of networks have a main mandate, which is enhances the management and sharing of the marine data, and to collaborate between the African countries and the institutions also. One of them, which we will take as example, is the Marine Atlas, Africa Marine Atlas. This is a very huge management practices and also serve as a hub, because with the Marine Atlas, we could share geospatial oceanographic data and also maps and satellite image, and the most important, high quality bathymetric data also are being collected in this network. So to make all of those information available for all the African countries is a must. We returned back to the gaps associated to the oceanographic for the ocean observation and monitoring in Africa. When we finished the study for the gap analysis, we find that we lack the maintaining of high technology equipment for ocean observation. Also, the cost of the research vessels, as we talked before, are extremely high. And in all of areas, this is beyond the capacities of most countries. And this is another problem. The participation, also we need to expand our participation in the Ocean Acidification Observation Network. As I saw today, number of our speakers are talking about the coral bleaching and the ocean acidification. So this is a must for us now all to join and participate in the ocean acidification observing networks also. We need also to develop and make better use of the collected data we had. Then we will search for, if we had ocean observing data supporting the evidence, how we could convince our policymakers. We first have to talk to them about the changes that have been happening globally, especially the climate change and the need of the monitoring, because climate change monitoring is not a day or month it changes. It's only over decades. We need years and years of monitoring to have our data and to have our database that we could based on and make our analysis to confess our policymakers. So by advancing the ocean observations, we could do this. And this is the way we should talk to the policymakers. Africa can provide them, the policymaker here, with accurate and reliable information. We couldn't do this without having this accurate and good instruments for ocean observation. Also, all the informations related to the fisheries, the aquaculture, renewable energy, and coastal tourism, all of those depend on the blue economy. They go through the blue economy, and blue economy means more money for the countries. So this is the language we have to use to convince our policymakers. Climate change impacts also affect all the countries, the pollution, the resource management, and how we could make our blue economy sustainable. We couldn't do this without ocean observation and monitoring. So, as we could say this data has driven approach to help our policymakers formulate effective policies. They have to work on their policies and make their policies, regulations, and international agreements to address the related challenges and to cover the gaps. And I will end here by this quote that is very important, that if we want to manage something, we need to know what it is. So we cannot manage what we cannot measure. This is another thing, stress on the importance of ocean observations. Thank you so much.
Thank you very much, Dr. Susan. This was amazing and clear presentation. Really, as you said, accurate data is the main issue, and it's everything. Without accurate data, we have nothing. Thank you, Dr. Susan. You talk more than your allowed time, but I was enjoying the presentation. Thank you again. And now I'm introducing Dr. Kouado Afyan, the chair of IOC Africa, Côte d'Ivoire. The title of his presentation, Marine Security, Sustainability, and Capacity Building Allowing Africa.
I didn't find you.
Welcome, Dr. Afyan.
Am I the floor now? Okay, thank you very much. Yeah.
You can start. Actually, Susan took all the time of the session, but we will give you all your rights.
Okay. Okay, thank you very much. What is the pointer? So, thank you very much. We are going now to talk about capacity development in Africa. No, I will use this one. Yeah. So we are going to talk about capacity development in Africa. So you know that the main challenge in Africa is capacity development. So just I will go around this topic and see how we can share information regarding to this issue. For this presentation, I will talk about the importance of oceanography in Africa. Then we'll see the current status of capacity development. Then we'll move to the challenges we face in Africa with regard to capacity development. And then we'll see the benefits of the potential benefits of capacity development. Then I will suggest some recommendations for capacity development in Africa, and then we'll conclude. So, in terms of the importance of oceanography in Africa, I think that many presentations have turned around this issue. We know the length of our coastline, how the fishery is very important for us, the maritime trade is important, biodiversity, and so on. So let's move ahead and see when we focus with regard to oil production, we realize that a quarter of what is produced over the world with regard to all pollution come from the Gulf of Guinea. So you see once again how the ocean is important for Africa. So when we try to see the current status of capacity development, Africa's vast coastline offers a wealth of opportunities, necessitating a robust capacity in oceanography. So when we see in terms of educational program, we have two types of approach. This team refer to two types of approach. Maybe we go for the degree program or specialized training. When we move to the research institution, we have to face existing facilities, Suzanne have talked about it, and what should be the collaborative efforts. In terms of workforce, we know that we have a number of experts in Africa, but we still face skills gap, and that is one of the concerns. In terms of infrastructure, we need to have laboratories and equipment. That is very important because when we are talking about capacity development, there are two sides. One side is infrastructure, the other side is human capabilities. So when we move around all this, we saw that we have some challenges. The challenges we have in Africa, one is the limited funding. Limited funding because we have money, we need to have money to acquire all this infrastructure. And the other thing is the brain drain. Personally, I don't believe that the brain drain may be a challenge for Africa because all these guys from Africa who move over the world, United States, Canada, and so on, I think that we can use the skills to empower people in our continent. So for me, it's not a problem. Brain drain, we can capitalize on brain drain by using all the citizens from Africa who are all overseas and use the capabilities. So we have also the governmental initiative. Here we face the policy framework. This is important because when we see what happened in Egypt here, I'm confident that if the government don't give the initiative to invest in this way, it's not possible. So we need to have this issue. And of course, the financial commitment. But the other thing we need in terms of capacity building is the public-private partnership. We need to have this set this collaboration, otherwise we face problem. So in terms of challenges, of course, the first one is the limited funding, of course, because in Africa, one of the main challenge we face is how to get this funding. We have also the inadequate infrastructure. Sometimes we have some, maybe when you move over Africa, you will find some oceanography centers and so on. But when we see closely, mainly they focus on fisheries. All these scientific things, going to CBIM, sea bathymetry, and seismic, they don't do. They only focus on fisheries. As we said, we have still gaps. Maybe if we have some skilled people in Africa, we have also this limitation. And there is also the institutional challenge. This is the limited collaboration we have sometimes you will see that there is very few interconnection between the institutions within Africa. So I'm happy that we have opened the door from the north so that in Africa, South-Africa collaboration, we can move forward. Also, the other thing we can emphasize on it is a lack of awareness. Sometimes our wording as scientific can't be understood by the decision makers. When we come to them and say the temperature of the sea is 11 degrees and so on, the decision maker don't understand. So how can we do so that we can say in wording that the decision maker can understand and come with us? The other thing we have as a challenge is the gender disparities. When you move in Africa, you will see that very few women are committed. And I'm very happy that Susan is very active. But if you move around Africa, you will see that all the oceanographers, more than 90% are men. So we need to push in this way to urge women to participate in this activity. And we have also the environmental concern, that is the resource exploitation, the climate change. So in terms of benefit or capacity development in oceanography, of course, we can underline the economic growth. We all concur that we can use sustainable fisheries, aquaculture expansion, natural exploration and exploitation, so on. Other benefit will be the environmental sustainability. As Suzanne said, you can't measure anything if you don't know it. The first step to measure something is to know it. If you want to know it, you need to measure, to have some information. So the other benefit from capacity development is the disaster resilience. If we want to achieve this disaster resilience, we need to make some study related to early warning system, and I'm happy that this forum focus on this issue, and we can move to the scientific advance, and that is another challenge, because anyway, if we want to measure sometime, I used to say that if you want you use optic approach, you won't find the same thing as if you use an electronic one. So we need to move forward in this issue. Again, with regard to benefit capacity development in oceanography, we have the economic diversification, the employment opportunities, because let's make sure that we can develop employment in this way, but also the international collaboration. That is very important, the international collaboration. You know, at the beginning of IOC, the thought behind the creation of IOC is the fact that it was said that despite the quality of the researchers, any skilled researcher can handle itself all the aspects of the ocean. And the other side, despite the power of any nation, itself can do the oceanography. So we need this collaboration to move forward. And also, when we have seen all these things, I suggest some recommendation for capacity development. So the recommendation of with regard is to enhance funding, Because if we don't have money, we can't do anything. The other thing I think it is very important is the curriculum enhancement. Because one thing is to make training and so on. The other thing is to propose a strong curricula for the training. So this is important to review and update educational curricula to include specialized course in oceanography, develop interdisciplinary program that integrate oceanography principle into related fishing. Because anyway, when you are talking about oceanography, all the fields are of concern. We talk about chemistry, you talk about physics and biology and remote science and so on. So we don't need to focus on only one disciplinary and say we are doing oceanography. The other thing we need to focus on is the research infrastructure improvement. That is very important because if you do not have the adequate infrastructure, it won't be able to move forward. Then I think that the international collaboration, I have already talked about it, is very important. And also the specialization of training program. Because sometimes what we face for a long time at IOC, when we are talking about capacity development, that just set a kind of seminar, 4 days, 3 days, and that is not benefit, I think. So we need to have the strategy so that we can empower the young people to develop all these things. And also, we need to have the community engagement. That is very important because anyway, if you you want to do something and you have not the commitment, the sufficient commitment, you won't move far away. And the other step we need to have is the incisive for skilled workforce. That is how to empower the researchers so that they can handle all these things. And we can't forget the government policies and support. I think that this morning somebody talked about this, maybe Professor Muda or somebody else. We have developed at each country some needs with regard for the concern of the country, but there is not this integration. You collect some data in Cote d'Ivoire, and if you can't link to the one which is collected in Egypt, somewhere you can move forward. So this is also a very big issue. And at the end, as I said formerly, we need to promote gender equality because if you see at the level of the world, we have fairly the same number of women as men. But if we put aside this population of women and try to move alone as men, I think that we will go a longer way. So all these things, I think, are very useful if we want to set best policy for capacity development. In conclusion, what I would say to mention is to standardize education curricula and training programs. Because, as I say, there is not science for developed countries and science for developed countries. If we are talking about science, the assessments are at the same level. So we need to standardize this educational curricula. We need to strengthen government policies and the commitment for sustainable oceanography. We need also to enhance public-private partnership for increased funding and technology transfer, because we need to focus, we need to base what we are doing in private sector. We also need to promote inclusively in capacity building initiative. And then, other thing we need to do is foster international collaboration and participation in global activities. We can't do something in isolation. We are in Africa, what we are doing, we need to link to China, to United States, and so on. And also, I think that we can prioritize community engagement and indigenous knowledge integration. That is very important, because sometimes we come to local people and we don't take care of what they do, and we come to propose them what we think, which is the truth. If we do so, we won't succeed. And finally, we need to invest in advanced technologies and research and develop initiative in marine sciencing. I think that this is all I would like to share with you this afternoon. Thank you very much for your kind clarification.
Thank you very much, Professor Afyan. That was very nice presentation. And I think, yes, collaboration is always the magic solution for a lot of problems. Now I'll introduce the audience to ask questions, just few questions.
Data sharing. So how do you actually do to standardize all kind of data? Because usually, for example, like a water quality data, so different season, different tide times, and sometimes it's different. So maybe some other acceptable geological data, maybe we can compare it in the same levels. So would you please talk a little bit? Thank you.
Thank you. As you see, during the presentation, we say that just exactly what you are talking about is one of our gaps, because we only have our national centers, data centers, and we control our data. So we know how we collect it, we know the exact time, the exact locations, and the methodology, and the important thing in the methodology. Because if you could start to collect data in different countries, they may use different methodologies, different ways of analysis, and this may make difference in the finalized data. From our gaps, as I had mentioned during my presentation, is we need to make a hub or a central data center for all the African countries. But for this, we need to have a certain type of data qualifications that all the countries have to be taken care. And so we could confirm that all the data have been collected in all the countries are under the same quality and confirmation. And to be honest, this is not easy at all, but we will try to do this, yes. Thank you.
Okay, thank you for question. It's very important question. What we are looking now, the first we needed to establish the workshop to make a standard format of the data. And we can decide what is the standard methodology we can working about that. What is the type of equipment we have. So from this workshop that we can discuss with Wantawi about that. So we needed to management the workshop maybe next month or after that to establish and understand what we have in all the African countries, what is the type of equipment. So what is needed to maintain some equipment. This is the second point. Third point, we make a standard format and we make a standard of methodology and the processing of the data, and make a correlation between these data in each site to get the standard data to introduce and finalize the hub we needed to get all of this data to be for all of us. This is to be understand what is going on. This is a very important. I tell you example for Africa in the Mediterranean. We have after the earthquake of Turkey occurred, we have increased the pressure about the Mediterranean, will make the Mediterranean sea level rise to go down. Many people don't know what is the reason. Is this for the earthquakes? Not understand what's going on. So, and Morocco asked me, I tell him when I visit Morocco, the problem is the pressure, increasing the pressure with the lunar of the moon. So what we needed to be contact not by each one time in year, no one time by month, but we needed daily contact to understand what is going on. Thank you.
Thank you very much. About this issue, I think that we have a challenge. A challenge is how to convert data. That is very important because the constructor of equipment, they never have a commitment between them to have a same principle to construct. That is our challenge is how to convert data. And if we want that we have the same logic to collect the data, I think that we have, with the constructor also, we can tell them that we have this challenge in data control, because data control is very important to make a decision. Because if we have a good data, we can have a good product. A good product can convince the policymaker to take a decision. That is very important. Thank you.
Just a few words with regard to this issue, to say that quality control is very important. And so far, up to date, in Africa, we have not a quality control strategy. And I think that we can do something interesting from this year. For the first time, after a huge fight, we have convinced IOC to have budgets for ocean observation in Africa. There had never been a budget for it. And I remember the fight we have with Professor Abunda to set this budget. So for the first time, we got budget for ocean observation in Africa. So with in connection with African Union and my own government, we have a meeting in May in Abidjan, and funded by AU and Côte d'Ivoire, so that we discuss this issue, and the budget we have, we are going to use it properly for all these issues. So we have good news. Thank you.
Yeah, thank you for all of the comments. And actually, I also have some comments for Go ahead. Yeah. So I think for the science or for the research itself, we should sit in the same level, no matter Asia, Africa, developing country, developed country. But so the one solutions, I think maybe we can share some knowledge between China and Africa. For example, yesterday, when we're approaching the airport, we see the desert and then see a green. The Nile River Delta is a very, very green, and So for my surprise, for the Nile River, the water looks quite clear from color at least, yeah. So actually in China, actually we did many research for the Changjiang River estuary, and as very heavy polluted, especially for the nitrogen phosphate. But I'm not sure how about the Nile River Delta. Not liking that, but it's yeah. So actually, we have many data and also experience. If we make a comparison between the Chinese liver system and Africa liver system, maybe Africa liver system is more nature. The Chinese has more anthropogenic forces like a lot of industry, fertilizer, also the liver activities there. So I think in the near future, we can do such kind of very politically comparison between the two systems. Actually, I'm also very interested to look at the real color from the upstream of the Nile River down to the estuary. In the Changjiang estuary, I have an image. I saw the very turbidity waters, and then always high harmful algal blooms, and also serious hypoxia and acidification especially in the summer. But I don't know how about the. Yeah. As the dams also regulated the water discharge and also regulated the nutrient supply. So I think actually for the nature for the ecosystem itself, Africa is very unique for scientists. But for the policymakers, we should provide some useful knowledge, transfer the data to knowledge and to the policy makers, as you mentioned, the data of the science-based or the data-based, evidence-based policy maker. Yeah, so I totally agree. Thank you. Yeah, thank you.
I think there is no more questions. Now we'll have a break, 10 minutes break. We'll come back 16:55 to continue the session. Thank you for you all. Thank you. Let me introduce Professor Cao Ji, National Marine Environment Forecasting Center, China. The presentation entitled Mazu Ocean Numerical Models and its Application Prospects in China-Africa Marine Science and Technology Cooperation. Professor Cao, you have 15 minutes presentation.
Okay. Good afternoon, ladies and gentlemen. My name is Gao Zhiyi. I come from the National Marine Environmental Forecasting Center. The title of my presentation is Mazu Ocean Numerical Models and Their Applications Prospects in China-Africa Marine Science and Technology Cooperation. The Mazu Ocean Numerical Models are a series of operational numerical models which include 5 members, including wave ocean and storm surge, tsunami, and sea ice. The Mazu numerical model developing project is proposed and supported by the Ministry of Natural Resources of China. It's aiming to praise the cultural spirit of Mazu. This project is carried by the National Marine Environmental Forecasting Center. Mazu model have relatively complete physical mechanism and adopt advanced numerical calculation method and computational acceleration technologies. The advantage of Mazu model include accuracy, efficiency, economy, and convenience. This means that the numerical model forecasting system based on these models are more economical and easier to deploy and maintain. Numerical model provide foundational supports for enhancing marine security and early warning of marine disasters and responding to extreme climate events. We are confident that MAZU model will play an important role in Sino-Africa cooperations in the aforementioned fields. I will talking something about MAZU. I know many Africa friends don't know the MAZU story. I will talk briefly. MAZU is a goddess of the sea in China, and also the goddess of peace in the world. She originally named Limor, was born in 960 on Meizhou Island in Putian. She spent her whole life on the sea, rescuing, and even set fire to her own house, using flames as navigation signals to get lost ships out of danger. At the age of 28, she sacrificed her own life to save people at sea. From then on, Chinese people worship her as goddess of the sea. In the 1980s, the UNESCO awarded MAZU the title of Goddess of World Peace. In September 2009, MAZU's belief in customs was included in the representative list of intangible cultural heritage of humanity by the UNESCO. This is the statue of the Goddess of World Peace. This is because we want to praise the cultural spirit of MAZU, so we name our model in her name. I will say something about the research and development background. As Alfie and other professors had presented, over 60% of the major scientific programs in the United States decade for marine science prioritize ocean observation and forecasting as key tasks. This is also advocated by the United Nations decade for the ocean of Africa. Because we suffered heavy wave disasters and chemical, biological pollution, drift, personal and vessel search rescue, also need numerical model to support. We also need a numerical model in global shipping, offshore engineering, and so on. In other domain of scientific, the ocean model play important role in atmosphere and ocean couple processes. On one hand, there is an urgent need for ocean numerical models in marine disaster warning and maritime activities and scientific research activities. On the other hand, the computational cost of numerical model is astonishing, and due to the limitation of the Powerwall, modern numerical forecasting systems are truly gold-swallowing beasts. It's not only scientifically enough, it's also a challenge of economy. The operational maintenance of numerical forecasting system is a heavy economic burden even for larger forecasting institutions, which is almost unbearable for small forecasting institutions. Therefore, we have to take action to break this bottleneck and establish new numerical models that are comparable in accuracy of the state-of-the-art models and can be affordable. We catch the tide of computation technology. So we have developed Mazu. It's based on CPU and GPU platform and perform super large scale to cover the whole global area with resolution about 1 kilometers. Let me introduce the Mazu wave model. This is inherited spirit of the third generation wave model in the world and innovatively apply the finite volume dynamic framework to the wave model. And so we call it the finite wave model. It's called FV1 for short. It has some characteristics listed below. This is the governing equation of this model. You can see we in the right panel, the wave field propagate in a physical space, but the model deal with the wave conditions in a spatial space. Is very complex. The physical mechanism include wave input and so on. This is the input, and there are some effects of temperature difference. And this is a nonlinear interaction source terms, and this is for wave dissipation caused by wave breaking. This is a source term for wave on ice interaction. There is a characteristic of our model. It uses the spherical centroidal Biruni tessellation mesh. This is the first wave numerical model use this mesh, and this is the propagation procedure. And this is the time step scheme for source term calculation. This is the supercomputation techniques used in this model. In this framework, you can see the mainly calculation load is prescribed to the GPU. GPU often used for display and game playing, but we can use this device to carry the scientific calculation. It can be used on a GPU scalable computing and use as lightweighted single GPU computation. If you use the single one, the device just about 30 centimeter plus 33 centimeter plus 12 centimeters. It's very compact. You can use it on your desktop. This is packaging technology. We package this model into a container. You don't need to install the software on your computer. You can draw the image from the net, from the internet, and just execute the software. You can produce the forecast field. This is the verification results of our wave model. You can see the wave height results is very splendid. This is the results of period results verification, which is very, sorry, it's timing. I use the timing. Okay. This is the result of view period verification. It is very good, and it perform better than ViewWatch 3, which constructed by the NOAA. Compared with ViewWatch 3, FV1 has comparable accuracy in wavehead and simulation. The higher record accuracy in view period simulation. The results listed in the right hand on the list. This model also used in operational application. There are some examples for the application in typhoon process. This model also used in our 19th Asian Games. Now, let me introduce something about the ocean model. This model is a mass-conserved ocean model, so it's called MACOM. This model is the first ocean numerical model established based on the conservation of mass theory. Is proposed by Professor Huang Ruixin. Other ocean models based on volume conservative theories. This is a governing equation. This model has a flexible grid processing model and a universal power framework. And you can see it can be used on several different kind of grid mesh. This is the numerical schemes, and we use similar computation techniques with wave model. It has also has some special weapons, just like data simulation and biological coupling, S-coupling. The accuracy verification listed in the right-hand table. We can compare our model with other state-of-the-art models. You can see FV1 support high scalability unstructured grid GPU acceleration, and is really cheap than other models, and convenience to maintenance. Especially, we can see just ViewWatch can support partially support GPU acceleration. So it is not economic as our model. This is the results comparison between ocean models. We have some serial advantage and some super computation techniques that other models. Is also capable to calculate the exchange of material in the upper layer of the ocean, and capable directly assimilate the seabed pressure observations, just like other professor just mentioned. The data collected around Africa can be assimilated in this model. Now we proceed to our conclusions. First, we are very willing to contribute Chinese wisdom to ocean disaster early warning service under the framework of Sino-Africa cooperation. Second, we warmly welcome friends from Africa and China to participate in the construction of the Mazu Ocean numerical model family. That's all. Thank you.
Thank you, Mr. Cow, for the impressive presentation. I really liked the idea of simplifying the very complicated modeling to this MASO model. It's very nice model. Thank you, doctor. Now I'm going to introduce Professor Yang, Fish Institute of Oceanography, NMR, China. The presentation entitled Recently Ocean and Climate Observation Activities over the Tropical Indian Ocean. Welcome, Dr. Yang. You have 15 minutes presentation. Go on.
Good afternoon, everyone. My name is Yang. I come from Center for Ocean and Climate Research, First Institute of Oceanography. And I'm happy to introduce the recent activities of FIO on ocean and climate observations over the tropical Indian Ocean. My presentation outline is separated into 3 parts: background, observation progress over tropical Indian Ocean, and the preliminary outcome and the perspective for cooperation. As we all know, the Indo-Pacific Ocean is a key region for the monsoon system, which is interactive with multi-scale atmospheric and oceanic variabilities such as the ENSO, IOD, ISO, and so on. But different from the well-observed and investigated Pacific Ocean and Atlantic Ocean, Indian Ocean is the most poorly sampled region of the tropics. There are still a lot of climatic and oceanic questions that need to be resolved and explored and resolved. As a result, the most densely populated countries around the Indian Ocean frequently suffers from numerous disasters and other extreme events induced by the monsoon system. Based on this situation, FIO first started the Indian Ocean operation in 2007, and cooperating with Indonesia, we first deployed the first balloon buoy and subsurface mooring in the East Tropical Indian Ocean as part of the RAMO program. The RAMO program only has 3 types of buoys, one from domestic Japan, and another from NOAA in US, and the last one came from China, which is developed by FIO. Here is the vertical structure of the balloon buoy. The sensors, we can see that the sensors can measure the temperature, salinity, and the density, as well as the current on the specific depths in the ocean. And the surface and the sea surface sensors can also measure the meteorological parameters such as the air temperature, pressure, wind, and the solar flux. This is the progress of subsurface mooring deployment in 2010, and this is the scientists of FIO and Indonesia. Also, this is the progress of balloon buoy deployment in the SIMCROS. Besides of the cooperation with Indonesia, we also cooperate with Australia, Thailand, and Kenya, and deployed a series of balloon buoys. Here we need to mention that the balloon buoy system has a real-time transmission program. That is, the data observed by the buoy can be transmitted through the satellite back to the base station and then be exhibited on GTS website and the mobile phone apps in real time. Also, we can send orders from the base station back to the balloon buoy in real time. And this is the apps in the mobile phone. So as long as you have a mobile phone, you can monitor the observations in real time. From 2023, we start to develop a new type of buoy. As introduced before, the original buoy can only obtain data in specific level, but for the new type, we can obtain continuous measurements as the wave-driven profile climbing up and down. This type of buoy can also be designed for plankton monitoring with smart camera and light equipped on the wave-driven profile. Also, the new type of buoy can be designed for vessel identification and alert, which can prevent ships from colliding with buoys. Besides the in-situ observation, we also conduct a series of joint cruises over the tropical Indian Ocean. The photo shown is the first Indian Ocean cruise for the research vessel Xiangyang Hong 01 from FIO in 2016. This is the investing stations and the cruise routines. And the FIO have two research vessels, which the Xiangyang Hong 01 is in 5,000 ton levels, and the Xiangyang Hong 18 is a little smaller, which is in 3,000 ton level. During this cruise, we have carried out multidisciplinary investigations, and this is the CTD casting and the water sampling. Also, we conduct CO2, marine chemistry, marine biology, and buoy deployment. We also conduct a series of joint observations based on the international cooperation. This is another joint observation during the negative IOD in 2017. Besides the common investigation, we conduct synchronous observations in vessel and Space Lab Tiangong 2 in tropical Indian Oceans. The right bottom photo is taken from the Space Lab, and the blue circle labels the vessel's location. We also visit the NOAA buoy during this cruise and provide useful information to the scientists of NOAA. We also conduct a series of joint cruises based on the international cooperation, and this is the China-Thailand joint cruise in late 2018. During this cruise, we make video plankton recorder measurements, and this is the China-Maldives joint cruise. This is the China-Kenya joint cruise. During this cruise, we deployed a set of balloon buoys off the coast of Kenya, which is the first set of buoy near the edge of the tropical Western Indian Ocean. Based on the observations, we also get some preliminary scientific results. One is the anomalous behaviors of whiskey jets in the equatorial Indian Ocean during 2013. And the data analysis and the numerical experiments illustrate that the anomalous changes in the equatorial zonal wind associated with the strong intraseasonal oscillation events are most likely the primary reason for such anomalous activities. We also explained why the Indian Ocean dipole was weak in the context of extreme El Nino in 2015. Based on the high-frequency observations from the buoy, we also described the diurnal ST response to tropical cyclone Dahlia in the East Indian Ocean. For the perspective, we hope we can make more cooperation with scientists from African countries and conduct more joint observations for ocean and climate over Western Indian Ocean and tropical regions, which can help us to understand the mechanism of extreme winds and diminish the damage of disasters over these regions. Thank you. That's all.
Thank you, Dr. Yang, for sharing us this impressive information. Thank you, Doctor. And now, let me introduce Dr. Jean Post, the Director Global Ocean Observing System, IOC UNESCO. Actually, she's not here, but she sent her presentation to be playbacked by video. The title of the presentation goes today, Building a Fit for Proposal Global Ocean Observing System.
I've mentioned already the need to respond to these many different policy delivery areas. It's not just about building observations, it's about building observations and identifying an implementation plan that can deliver into the needs of countries and how they want to respond from the country level to these many different challenges that they're facing. We are, of course, we are the global voice on ocean observations. We are placed within the UN system to provide this global voice, and I am keen that we are the sort of conduit in which that can be helped, and I encourage everybody to contact Goose and ensure that we can help countries in the region. We are limited, of course, with financially with what we can do, but we hope very much to build this coordination, this advocacy, this delivery, and eventually, of course, hopefully to bring the financing identification and the cost benefit at the country level to support activities. And particularly, as I've mentioned, and as I'm sure is being discussed in this symposium, to build the national capacity and the regional capacity in Africa moving forward. And this final slide just shows you the different regional alliances that Goose is working with. We have a focus really on supporting IOCARIBE, our Caribbean Goose Africa, the IOGOOSE in the Indian Ocean Basin, and the Pacific Islands Goose. And we also, of course, have recently had a national focal point meeting to look at how we can increase capacity at the national level to, first of all, identify the needs for ocean observation, to identify and bring together a group in country that can really set in motion an observation identification plan, and ultimately delivery and identification of needs in that area in collaboration perhaps with regional level alliances. And with that, I'd like to thank you very much for your attention. I wish you a very successful conference over the weekend, and I'd be more than happy to stay in touch and wish you very well. Thank you very much.
That was very informative presentation from Dr. Joanna Post. Thanks for her. And now I'm introducing the audience to invite questions. If anybody have a question about the previous presentations, we arrived to the end of the session. Thank you for you all, and good day. Have a nice day. Thank you.